Hi, so we are in the last module before the test, and this is kind of a mishmash of the last few sections that from a variety of chapters that all have to do with the topics we've been working on, like decimals and whatnot. And the first page you have is this page you see on your screen, not the first page, but the next page where we left off after those discount problems. The next page says writing and solving percent proportions. However, I've decided to skip this because we've already done this kind of stuff in a previous section in chapter 6. And also, this is the module where the test is due. So I wanted to shorten the homework a little bit and give you more time to focus on preparing for that test. And as a reminder, there's that student review test center available. If you haven't seen it, just shoot me an email, let me know. I will make it more visible. And that's just something you could do to practice for the test, as well as just looking over all your notes and making sure you have your notes organized and you have your calculator handy right before you start the test. Okay, so we are actually going to start with 10.5, which is scientific notation, and some operations with scientific notation. So scientific notation is very important in science classes. That's why it's called scientific notation. And it's just a quicker way that we can write these numbers, more condensed. And so for scientific notation, the number is always going to be, so I'll call it an A, that's usually what letter we use. Our number is always going to be between 1 and 10, and we can include 1, but we can't include 10, because if we wrote it if we could write it as 10, then we could just move the decimal and rewrite it as a 1. So we want to include 1 in every number all the way up to, but not including 10. And then it will be times some power of 10. So this is kind of a confusing way to write it, but it's just a mathematical or symbolic way of writing what you may have already seen before in science classes. So what it's saying is move the decimal to the place where you get a number between 1 and 10. So I have my decimals always at the end. If you can't see it, if we have a whole number, the decimal's at the end. And when I want to move it right here, so then I have the number 2.52. However, you know that 25,000 is not equal to 25, so we need to say how many places we moved it. And so we moved it over 1, 2, 3, 4 places to end up at 2.5. So I need to multiply 2.5 times 10 to the 4th power. I moved that decimal over 4 places, so I'm going to say it's to the 4th power. 10 to the 4th power is 10,000. So what I'm saying is it's 2.52 times 10,000, and that will equal 25,200. Okay, we'll try it again. Part C, 2020. I'm jumping to part C because that's also a whole number, so it'll be very similar. I have my decimal at the end, and I'm going to move it 1, 2, 3 spaces to give me the number 2.02. And then I'm going to multiply that by 10 to the 3rd power because I moved that decimal over 3 places. And I forgot what I was going to say, but I'm sure I'll think of it in a minute. Oh, I know what I was going to say. That scientific notation is always written with an X. I don't know why. It's probably scientists wanted the times to be X. I'm not sure, but we don't put like sometimes you'll see a star for times, or sometimes you'll see parentheses for times, but in scientific notation, it's always the X for times. Okay, so on part B, I have a number less than 1. So in order to get it in between 1 and 10, I need to move the decimal over to the left. And I only need to move it over 1 place to get the number 3.57. But since I moved it over to the left, I need to have a different way to indicate that we're moving to the left. So when we move it to the left, we're going to use a negative exponent. So small numbers have negative exponents. big numbers have positive exponents. And so since it was less than 1, it was a small number, it had a negative exponent. Part D, we move the decimal over 1 space, 2.036, and that will give me 10 to the positive 1 because I have a big number. Now, in hindsight, I might have just said left when I meant right or vice versa. I tend to do that all the time. So what a better way to say it is big numbers have positive exponents, small numbers have negative exponents. And that same rule is going to carry over to part 2. So let me just write that out. Big numbers have positive exponents and small numbers have negative exponents. So in number 1, you saw if the number was big or small, and then you wrote the exponent as positive or negative. The opposite is true in part 2. We can see the exponents, and we have 2 positive exponents and 2 negative exponents. And then we're going to write the number. So since 4 is a positive exponent, I know the answer to A is going to be a big number. So I start off with my 2.8, and then I'm going to move it 4 places, 1, 2, 3, 4, and we get, I'll just rewrite that, 28,000 as our number. That is our big number. If I had moved the other direction, I would have ended up with a very tiny number, and that would have been wrong because the exponent's positive. So let's jump to C because it also has a positive exponent. So I have 3.0, and I'm going to move the decimal 2 places. Since it's positive, it's going to be a big number. 1, 2, that's the number 300. And that makes sense because this is a 3, and a 10 squared is 100. So 3 times 100 is 300. All right, for part B and D, you'll notice we have negative exponents. So this 3.75 is going to get even smaller. So I move the decimal to make a small number, 1, 2, 3 places. So that decimal ends out in front. And I'm just rewriting them so you can clearly see where the decimal ends up. Some of these problems end up looking like I have 2 decimals in them, so I just like to rewrite it. One last time, 7.25. I have a negative 1 as my exponent, so I want to make this smaller by moving that decimal out in front. 0.725 is my final answer. The first 2 problems are just about practicing writing our numbers in scientific or decimal form, and it's just about moving the decimals. Now for part 3 and 4, we are multiplying or dividing, one of each, using scientific notation. And so we can multiply or divide these problems, and we can do that without, when we have this multiplication, we can do this by grouping the numbers together. So we have 2 times 3. Actually, we should probably just write them in scientific notation first. Okay, so we have 2. The decimal is moved over 1, 2 places. This is getting all kinds of messy. Let me just start fresh. We have 2. We move the decimal 1, 2 places, so we end up with 0.02. Then we have 3, and we're going to move the decimal 1, 2, 3 places. These numbers are getting smaller, so we have 0.003. Okay, that's the problem. And now you'll notice I really just have 2 numbers, 3 times 2, because everything else is a 0. So we could actually just do this multiplication in our head, and it doesn't turn out too terrible because we have 2 times 3, which is 6. And then I would move my decimal 1, 2, 3, 4, 5 places in front. And that number I'm going to keep in my head, 5 places. 1, 2, 3, 4, 5 places in front. Just to give you an idea of what it looks like. Some of you might have used your calculator, so I just want you to have an idea of what the number looks like. But the goal, the final answer is going to be to write this in scientific notation. So our final answer is going to be 6 times 10. Now, we moved it 5 places, and our answer was a tiny number. So that's how we end up with 10 to the negative 5th for this problem. It's a little tricky. This step from here to here, you can either do in your head or you can do on your calculator. It's fine either way. What I'm most stressing in this problem is how to get from your answer to the scientific notation. That's the most important part, because just like before, I've said this in other sections, the way the question is asked is how you should answer it. So if the question is asked in scientific notation, the answer should be in scientific notation. Okay, for 4, we have 6 times 10 to the 5th. So I'm going to move my decimal 5 places. I'm going to make a very big number because this is positive. 1, 2, 3, 4, 5. So that gives me 600,000. There is a way to do scientific notation on your calculator. It is the problem with it, with doing scientific notation on your calculator and me being stuck in this video, is everyone's calculator does scientific notation a different way. So if you're really that interested, you could Google the model of calculator you have, or you could look at the instruction manual that came with it. But it's just too hard for me to explain it quickly, because so many different calculators have different ways. I could tell you how to add on your calculator very easily, because almost every calculator adds the same way. But scientific notation is a little trickier. So you can just Google it, or you can always take a picture and send me your calculator and we can just talk about it. Okay, and then we are dividing by 2 to the negative 3rd. So we're going to move our decimal to make a tiny number, 1, 2, 3. That gives us 0.002 is what we are dividing by. Now, I don't know if you are predicting what the answer is going to be, but it's actually going to be quite large. So we're dividing 600,000 by 2 thousandths, and we end up with a 3 and a lot of zeros. You probably saw the 3 coming because we have 6 divided by 2, but we have 8 zeros after that 3. I could fill in with some commas, and that gives us 300 million. And so finally, our answer is 3. And then since we had 8 zeros, it's going to be times 10 to the 8th. And if you don't quite trust that, you could just count it. 1, 2, 3, 4, 5, 6, 7, 8. And so our final answer is 3 times 10 to the 8th. Again, this middle step, calculator, is perfectly fine on that. But this last step, that's where you're focusing on converting your answers. And that is it for scientific notation. So go ahead and pause the video, do all that 10.5 homework, get it out of the way, and then come back and we will finish up. And we are back. So 5.1a, we're going to be writing ratios and using ratios in applications. And so what this is about is kind of putting decimals and fractions together. And it just kind of wraps up everything we've been talking about since the beginning of chapter 4, because this has to do with fractions and it has to do with decimals. And so a ratio is just a fraction where the first number goes on top and the second number goes on the bottom. We'll just write it as 15 over 75. And then we can reduce it because we always want to have our fractions in simplest terms, but 15 over 75 is going to give us 1/5 as our final answer. 15 goes into 5 one time, 15 goes into 75 5 times. Okay, so trying that again. Now you'll notice these fractions are getting a little trickier because here we have our first number on top, our second number on the bottom, and it says we want it to have whole numbers because leaving decimals in a fraction doesn't make sense. It's not how we write our answers. And so what I want to do is I want to move the decimal the same amount of times on the top as on the bottom so that I have no more decimals left. So on the top, if I move the decimal 2 places and I get 27, I have no decimals anymore on the top. That's perfect. But I have to do the same thing on the bottom. So a mistake that people make a lot is they just move it and they call that 54. But that's not going to be 54 because we have to move it 2 places and fill in the 0. So it's actually going to be 540. And then we have to reduce. So 27 goes into 27 one time. 27 goes into 54 2 times. So it goes into 540 20 times. So our reduced fraction answer is going to be 1/20. And so now you can see we're kind of mixing up decimals and fractions in this chapter. That's why I saved it for the end, or in this section. Okay, so now finally number 3, we're writing a ratio of 4 6/8 to 2 1/2. And so this turns out to be something we talked about in chapter 4, a complex fraction. So we have 4 6/8 over 2 1/2. And so what I want to do is I want to treat that as a division sign in order to simplify this because I cannot cancel out, I can't even write on it because it'll mess up everything, but I can't cancel out that 4 and 2. That's not how we do this. We need to make them into mixed numbers and divide. So the reason that, so first I'll make them into mixed numbers. So on top we have 8 times 4 plus 6 more, so 32 plus 6 is 38 over 8. And on the bottom, we have 2 1/2. So 2 times 4 is, 2 times 2 is 4, plus 1 more is 2. Now, if you saw that 6/8 and you wanted to reduce it first and write 3/4, you absolutely can. That would change this problem, but it won't change the answer. So just remember, whenever you're doing these things with fractions, you can always reduce along the way to make the problem a little simpler for you, if that helps. And I will be reducing it in just a second. So the next step is to say that this fraction bar is really a division sign. So instead of 32/8 over 5/2, I wrote 32/8 divided by 5/2. And going back to KFC, that means 30, I think I said 32 earlier. My numbers are getting mixed up today, but I'm writing it correctly, so I might be saying it wrong, but the writing is correct. So we have 38/8 times 2/5 because I kept the first one the same, I flipped the second one, and then I changed the operation to multiplication. And so I cannot reduce a 38 and a 5. I can reduce a 2 and an 8. And then I can also reduce a 32 and a 4 because they're both even and they're both, one's on top, one's on the bottom, so they're both eligible to be reduced. So I'll do that in green just so I don't get too much red on here. But 38, 2 goes into 38 19 times, 2 goes into 4 2 times, and I am done. I cannot reduce anymore, so I will end up with 19 over 10 as my final answer. So it said to write the ratio as a fraction, not as a mixed number. In the past, I've said you should always write the problem the way the question, you should always write the answer the way the question is asking it. However, this is being very specific. It says write it as a fraction. And it says that in every problem. Write it as a fraction, write it as a fraction, write it as a fraction. So that means reduce it, but it means no mixed numbers and no decimals in your final answer. Okay, so that's the first part. And now we're going to use these ratios in applications, in word problems, in order to solve some things coming up. So it says find the patient's ratio of total cholesterol to HDL cholesterol in fraction form. So I like to write it out what they're talking about. We're talking about total over HDL because it says the ratio of total to HDL. That means total goes on top, HDL goes on the bottom. So the number with total is 175 milligrams per DL. Not sure, I'm not a doctor. And then 60 milligrams to DL. Now what's important to notice here is ratios don't need units. And I wrote the units to show you that we don't need units, because what happens here is they are the same, therefore they will cancel each other out. So our final answer will just be a fraction. So I'm going to look at 175 over 60, and it reduces to, because 5 goes into both of them, 35 on top and 12 on the bottom. So the final answer is just 35 over 12. We want it in fraction form. That's what the problem asked for. And there are no units because the units canceled each other out. Now, units are important to pay attention to, and you'll notice that on number 4. This is find the ratio in fraction form of the first length to the second length. So the first length is 16 inches, and the second length is 1 foot. But we cannot cancel out those units, so this is not going to be our answer. What I need to do instead is make them the same units. So instead of 16 inches over 1 foot, I'm going to call this 16 inches over 12 inches, because that's the same. 1 foot and 12 inches is the same. And so now I can cancel out the units, and I can reduce 16 over 12 because 4 goes into both of them. And the final answer is 4 over 3. Please pay attention to the units. When you have different units, there will be a little extra step in there. And that's where people get frustrated on the homework, because they misread the problem and they don't use the right numbers, and then they get it wrong, and it just kind of creates a mess. So pay attention to the units. Once the units are the same, you'll be able to cancel them out and have your final answer. Ratios have no units. And I really encourage you to take a break right now, because this next section is similar but different, and I don't want you to get the two mixed up. So go ahead and take a break, do the homework assignment, and I will be here when you get back. And we are back. We're going to do unit rates and unit prices, and that is the last section. Yay! And then we will be done with this whole packet. Went too far. Okay, so unit rates and unit price, these have units. Now, the word unit means one, but it also means we need to have units in our answers. And so we are not going to leave them as unreduced fractions. Well, we might, let's just see how this goes. Okay, so Casey walked 52 miles in 8 hours. So I don't go around talking like 52 miles in 8 hours. How we say it is miles per hour when we're driving a car or running or whatever we're doing with these rates. And so what I want to do is I want to reduce the 52 over 8, but I also want to leave the units of miles per hour separate from the fraction. So I'm going to reduce the 52 over 8. 4 goes into 52 13 times. 4 goes into 8 2 times. So the answer will be 13 over 2. And the way we write it is mph, miles per hour. You could also, oh no, we want to leave it like that because it says to reduce. It doesn't say to write it as a decimal. So I reduced it. Number 2, it says $5 per is another way to say to write it as a fraction, 64 ounces. And this problem, I probably will write as a decimal because we talk about money in decimals. We don't talk about money in improper fractions. So what I want to do, I'm just going to put a little thought bubble. It's actually a little calculator bubble because you want to do this on your calculator. 5 divided by 64, and we get a yucky number. 0.078125. That came from the calculator, but since we're talking about money, we always want to cut it off right here. Let me get a different color. Cut it off right there. And so we're going to say that this is $0.8 per ounce. Oops, that's supposed to be a Z in cursive. You don't want to say, well, be sure you're clear on your units between dollars and cents. Another way I suppose you could write it, this one I don't love, would be 8 cents per ounce. The reason I don't love it is because now we don't have the same units as the problem. And so on the computer, if you just typed in an 8, you would probably get it wrong. So this is the much better way to write it. And the reason I rounded was because we were talking about money. All right, last one. We have a typist writes 190 words in 6 minutes. So we want to know what are her words per minute. So that's 190 words in 6 minutes. Notice the units, none of these, the units don't match on anything. And so that's fine. We just need to keep the units and not try to reduce them out of our final answer. We can just reduce the fraction. So here, these two numbers are both even. 2 goes into 60 times. 2 goes into 190, 95 times. And so we say 95 thirds words per minute. So we're just practicing reducing those fractions and not reducing the units. Okay, so now that is exactly what we're doing here. We are finding out the unit rates. I think these will divide a little nicer here. But we have 144 feet in 3 seconds. How many feet or how far does the skydiver fall per second? So I'm doing 144 divided by 3, and I get 48, and I keep my units, feet per second. Alice scores 64 points in 4 games. Those 64 points, the first number goes on top. 4 games, the second number goes on the bottom. How much does she score per game? So we're going to divide 64 divided by 4 and get 16 points per game. So we have both units, I guess you could call games units. We have both units that were given in the problem stay in my answer. Over here I had feet and seconds, and so I have feet and seconds in my answer. Finally, miles and hours, so I'll have miles per hour in my answer. So this last one, we have 12 miles in 3 hours. So we end up with 4 miles per hour. And that one we can just say MPH. That's a very common abbreviation That's how we talk about speed, and whenever we use that rate, we use MPH. Okay, last one is the unit price. This is how much things cost for a certain unit. This is how we compare things. So if you want to know how much a taxi costs per mile, so you can compare two companies, this is how we're going to do it on number 7. Number 8, well, I'll talk about number 8 in a minute. So let's do number 7. We have $32.40 over 12 miles. Now, you'll notice I put the first number on top and the second number on bottom. If you are ever unsure, look at what it's asking you to find. It says find the cost per mile. That means cost goes on top, mile goes on the bottom. So I'm going to put $32.40 in my calculator and divide by 12. And I get, my calculator says 2.7, but since we're talking about money, we have to fill in some stuff. So we have to fill in the dollar sign. And then money always goes to the nearest penny. So we put $2.70 per mile. I have the dollars and I have the miles in my answer. Okay, the reason this is handy, number 8 and number 9, this is really the most reason the unit price is handy in real life. And so what happens is we have these 2 different containers of peanut butter. One is 18 ounces, one is 36 ounces. And we want to find out which one is the better buy. Now, of course, the bigger container is going to cost more money. But sometimes it costs more money and it's actually cheaper than buying, say, 2 of the smaller containers. And sometimes it's more expensive and they just get you because they don't think you're checking. So we're going to find the unit price for each of these, and then we will say which one is the better buy, and that means cheaper. So we'll start off with the 18-ounce container, and that is $3.99 over 18 ounces. Money always goes on top. If you do these backwards, you will always get the exact wrong answer. Money goes on top because we want to know how much money this costs per ounce. So the unit price is the cost per whatever you're talking about. Many times you're talking about ounces. Sometimes you could be talking about pounds or gallons or other units. Okay, so $3.99 divided by 18. And I'm going to get a very small number, 0.22. And then a bunch of 6s. And that's really all I need to write because I need to know to the nearest cent. And that's enough information to round to the nearest cent. So now I'm going to do the 36 ounce. And this one is $6.99 per 36 ounces. So now I can type in $6.99 divided by 36 ounces, and I get 0.194. I wrote it backwards. 0.941, and then there's a bunch of 6s, and then a 7. And so we're rounding to the nearest cent. So I'm going to put that in blue to compare. We have 22 cents and we have 19 cents per ounce. And so the final answer is going to be the 32-ounce container because that only costs 19 cents per ounce, whereas the 18-ounce container cost 22 cents per ounce. So we want to know which one is the better buy, or in other words, which one is cheaper. Okay, let's try that again. Same idea, but now we're buying noodles. And so we have noodles cost 79 cents for a 16-ounce package and $3.49 for a 32-ounce package. Which one is the better deal? So I'll start off with the 16 ounces. And notice this first number is in cents and the second number is in dollars. So I'm probably just going to put both of these in dollars. So 79 cents is $0.79. So we have to make sure the units match up. But I have $0.79 over 16 ounces. And I put that in my calculator. And again, we're going to the nearest cent. And I get a pretty small number, 0.0493, and well, probably, I'll just round it here. We'll round it in a minute to the right answer. But I just want a couple decimal places there. And I'm going to do it for the 32-ounce package. Now, some of you go shopping enough, you could probably just look at this and see one's better deal. But some of you, well, you probably all go shopping, but some of you go shopping, you don't care. So either way, let's make sure you know how to do it. So this next one is $3.49 per ounce, or per 32 ounces. So I put that in my calculator. And I get 0.10906 and so forth. Okay, so looking at these two numbers, I have, that's 5 cents per ounce because I'm rounding up. And this one is 11 cents per ounce because again, I'm rounding up. And so we can see it's actually a lot cheaper to buy the smaller package. If you want a bunch of noodles, you should just buy more of the smaller packages because it's much cheaper per ounce. So sometimes you're going to have the bigger package be cheaper. That would be like going to Costco. And sometimes you're going to have the smaller package be cheaper because maybe the smaller package is on sale, like at Save Mart or something, and it just turns out to be the better deal. So better deal or better buy means which one is cheaper, which one is less money. All right, so that is it for this module. Take this extra time this week because there's less homework sections to prepare for the test. I said week, you know what I mean, this module. And email me if you have any questions. All right, thank you.